All right, ladies and gentlemen, we're going to start part 3 of your final exam review. And we're going to start with question 41. In question 41, you basically have a diagram. And it has asymptotes at -1 and +1 for x. So imagine, if you would, as you see on your diagram, this is your function cutoff for the asymptotes. And what I want you to notice is that the function is going up on this side. It's kind of has this shape. And over here, same difference, is going this way. And at -1, it's going to -infinity. It's sort of plateauing, going through 0 and coming back up. Oops, that's horrible. Let me do that one more time. So once again, it's going up, it's going to plateau, and it's going to come through +1 as such. So the question in 41 talks about concavity. They're asking, where is this concave down? So concave down, I'm looking from -1 to 0, it's facing down. And also from 1 to infinity, it's concave down. It has a point of inflection at this origin. If you notice, it's continuing, it's going up, and it continues going up. But it does have like a question mark here where it's like, which way do I go? And it does continue in the same direction. So in this case, I would answer negative, that's not what I meant to do. -1 to 0, as I stated earlier, -1 to 0. And I would say from 1 to infinity. And those are the points where it's concave down. You notice the direction. And at x equals to 0, I have a point of inflection. I believe that's answer choice D in your test booklet. Question 42, more of the same. They give you a graph, and at about -2, this diagram sort of does this bowl-like shape. And the question is, where is it concave up? Where is it concave upward? Remember, that's a second derivative test. And it looks like, in this case, from -infinity to +infinity, this is definitely concave up, and there are no inflection points. (43), more of the same. They give you another diagram. And so as we're looking at the diagram, it is going through 0. It's going through about 4.5, back in the opposite direction, -4.5. So it's kind of like having this kind of behavior as a rough estimate. The question is, they want to know where the second derivative is positive. I would argue that it's concave up from here all the way through here. And that's what they're asking. The notation they're using is, where is the second derivative greater than 0? So I would say from 0, remember this is infinity, so 0 to infinity, I would say it's concave. Here on this side, I would argue that the second derivative is less than 0. It's concave down. So concave up, concave down. All right. Number 44. They're asking us to find the second derivative given that y is -1 over 3x plus 4. So I would begin by differentiating, basically. So we start with bringing the 3x plus 4 up. So we would have y equals -1 times 3x plus 4 raised to the -1. And if I differentiate, I'm going to multiply -1 times -1. So my first derivative starts with +1, and then this becomes 3x plus 4 to the -2. Okay, if I differentiate again, my second derivative becomes -2 parentheses 3x plus 4 to the -3. And then now we're in chain rule, so times 3, you have to take the derivative of the inside. This gives me -6 parentheses -6 times 3. I have to differentiate once again. I think I missed a step, or I went too quick with the this is first derivative, second derivative. So yeah, I should have -6 it should be times 3 over 3x plus 4 to the third. I'm missing something. I don't know what is it that I'm missing. I think I missed the 3 here. That's what it is. So this should be, that's what it is. Yeah. And so we end up with -18 over 3x plus 4 to the third. Let's see what the answer choices are. It looks like A is the winner. A. So it is -18. I don't know why this one's bugging me, but that is definitely the correct answer and the correct steps. All right, number 45. All right. Number 45, they give you f of x is equal to e to the x over x cubed. So I'm going to go ahead and let's just go ahead and graph this first and see what happens. All right. So we're looking at this equation and they want us to find the absolute minimum value. Okay, so I'm looking at, let me see if I click on this. That looks like the minimum value right there. You just sort of trace it. I remember I said questions like this I may not even include in the test because they're not going to have access to a computer in the classroom, and even on the TI, D3, D4 calculator, some of you may not have that calculator. Just FYI, it does benefit you to have it. I believe this is one of our answers. It should be answer choice D as in dog. So that should be fairly quick and dirty. Okay, let's take a look at the next one. I think the next one is another one that I may or may not So this one simply graph to find the minimum. 46 is another one of those that I may or may not include in the test because of the size of the example in terms of graphing it. So if you were to graph this on Desmos or any other technology, you would have to be very cautious with the window that you choose as far as the window selection. So they want you to look at it in the interval between x is -6 and 2, so inclusive. So you could throw this into y equals and solve for it that way in the calculator. So let's take a look and see if that works for us. If it's something you could potentially do. If you have a TI 8384 calculator, let's see. I'm just gonna let it run. All right, so let's go to y equals. And we're gonna put in our equation. It's so picky. 9x raised to the third minus 54x to the second power plus 81x plus 13. So once you do that, you can go to second graph, and they're looking for, notice that this is already telling me that there's something funny going on here. I'm thinking possibly at 1 is equal to 49. And then I want to check the -6, which is our boundary. So even though this is lower as a minimum, they're not asking us for -7. They're limiting us to -6 and 2. So -6, 4361. So that's definitely one of the answers. So I'm eliminating answer choice B and C, and it's either A or D, and we already showed that it looks like I have f of 1 is 49, whereas A is reversed in terms of max and min. So I think the minimum is definitely -6, -4,361. And according to our interval, the max definitely would be the +49. So that's how I would answer that one. That would be answer choice D for this one. All right. Number 47. Number 47 says the percent of concentration of an acid absorbed in a new manufacturing process after X hours after the acid has been mixed is given by, and they give us the function A of X is equal to 4x over x squared plus 49. Okay. How long after the acid has been added to the concentration is the concentration a maximum? And then it says round to the nearest tenth. So I'm thinking graph and trace this one. It's easy. Let's graph and trace. I'm also curious if we did differentiate, if it would make a difference. But let's graph and trace it first. Keep it simple. So at this point, we're looking at 4x divided by x squared plus 49. All right, look carefully here. Do you notice that there is the inundation? They're asking for the maximum, so it's definitely not down on the left side of the 0. Let's graph it here. Look at your y values. They're definitely going up. And here I am at 2.86. So stop and notice. Look what's happening. It's dropping from here, right? So 286 and then 285. And over here 285 down. So it looks like this is your max right here. And you can tell because at x is 7, you reach the highest pinnacle of 2.86. 0.286. All right? All right, so that's what I would do for that one if we were to include this in the test, question mark. On 48, we're looking at the absolute minimum. They're giving us f of x is equal to 4x plus x squared plus 2. So if we re-express this, this is really x squared plus 4x plus 2. If I take the first derivative, notice that I get 2x plus 4. If I factor out the 2, I get x plus 2. So possible solution in this case, -2. There's also a possibility of 0. There's always a repeating 0. If we do negative b over 2a, I don't know if you're familiar with that, but that's the axis of symmetry. Negative b over 2a equal to x. So if we do that, we would get -4 over 2 times 1, which also gives us -2 as a possible x value. However, I would go again, we're looking from the interval from 0 to positive infinity, which technically never has a bracket. I should have known that better. There's always parentheses for infinity. Let's play devil's advocate once again. Let's go to a graph and we'll just look at the max and min of the function. So according to this, x squared plus 4x plus 2. And we're looking at this from 0. So it has to start at 0 then. So if you notice at 0, I'm at 2. So the absolute minimum in this case would be x is 0, y is 2. Because from here, from 0 to infinity, this keeps going up and up and up. It would be max after that. Okay, 49. Find two numbers whose sum is 230 and whose maximum and whose product is a maximum. If there are two numbers that add up to 230, the first thing I'm thinking of is divide by 2 and you get 115. So add 115 plus 115, we get 230. If we multiply these two numbers, this would have to be the answer, which I believe is answer choice B. I can't get any easier than that one. Next question is similarly as easy. On number 50. Carpenter is building a rectangular room with a fixed perimeter, so we know the perimeter is equal to 560. What are the dimensions of the largest room that can be built, and what is the area? So first thing I would think of is twice length plus twice width I love how I say length and width and I write down the absolute opposite. And this is equal to 560. So that means that length plus width is equal to 280. And if that's the case, I can solve for length as 280 minus width. I know as far as the area is concerned that length times width is our area. So in this case, 280 minus W, which is our width or our length, times the width, according to this, should be 280 W minus W squared. Once again, negative B over 2A. So negative 280 divided by 2 times negative 1 gives us 140. So 140 times 140 gives us our largest, biggest area of 19,600. So I believe that's answer choice C. Okay, so that is what was this 50? Okay, here's 51. So as you read this question, I want you to understand that the hotel room or the hotel establishment has 60 rooms, and they are currently charging $40 a night per room. And keep in mind that according to the question, it says if each room costs $8 to service, so they still have to pay $8 out to service a room. And this gives us approximately a profit of $19.20. And they want to see, suppose the management determines that for each $2 increase in the nightly rate, so they're going to charge $42 in a nightly rate. But remember, based on this, they are estimating they're going to lose 5 rooms, so that's now 55 rooms that they're renting at $42 minus the $8 service, and that comes to approximately $18.70. It makes absolutely no sense that they change the rate, so leave the rate alone. So that's just using common sense. I believe that's answer choice C for the question. Okay, question 52 is another one of these where you would actually have to determine, let me see. So this is what they're giving you. They're giving you the average manufacturing cost. It looks like average cost. It's 2x to the third minus 42x to the second plus 288 plus 12. And they're looking at this from the interval between x is 1 to x is 5. If you simply graph this, you can actually solve this quite easily. So again, one of those questions where if you go to Desmos, we're going to throw this in here into Desmos. So we have 2x raised to the third minus 42x plus 288x plus 12. And as I am looking at this, actually, you know what? An even easier method, I think, for you, and I think all of you should be able to do this. You can do this by hand or with the calculator, it's up to you. I'm going to go ahead and I'm going to throw this into the graphing calculator, which again, you can do this by hand by just multiplying these terms one by one. And it's not that bad. I think I have a harder time typing it in sometimes. So I'm just going to keep clicking away. Plus 288 plus 288x. Okay, I'm going to just type that equation in there. Let's go to the table. And we're looking at it on the interval from x is 1 to x is 5. At 5, I'm at 652. And at 1, I'm merely at 260. So it's going to increase all the way up to 5. So 652 is our highest. That would be our maximum. So 5 units. Simple. That's how simple that is. I think that's the easiest way for you to attack that question. Okay. Let's look at the next question. This is number 53. Now 53, we start with antiderivatives integration. And so we have the following equation. They're simply asking us to find the integral. So we take 3x to the 8th power minus 7x to the 3rd plus 9. So remember, this is 9x to the 0. Just for the record, I'm just going to write it for you. So we're going to go with plus 1 here and divide by 8 plus 1. I'll go plus 1 here, and I'm going to divide by 3 plus 1. Go plus 1, divide by 0 plus 1. Okay, and I'm just being extreme and writing each part so you see it by parts. I mean, we can even go further and integrate, as 3x to the 8th minus integrate 7x to the 3rd. We can get really formal. Okay, we can get really formal. So this reduces to basically 3 over 9 with x to the 9th here, minus, and this reduces to 7 over 4, 7x to the 4th over 4, and this is plus basically 9x, and then plus c. What reduces further is the 3 over 9, obviously that reduces to 1/3. So it looks like your final answer should look like answer choice C in your test review. Okay, let's continue with number 54. Again, we're finding the integral. They're giving us 5 parentheses, we have t squared minus 5t minus 2 dt. Okay, so if we distribute the 5, you're going to end up with 5t squared minus 25t minus 10 dt, and then integrate, or add 1 to the exponent, divide by 2 plus 1. This is already a t to the 1 plus 1, divide by 1 plus 1. And remember, this is x to the 0. We're going to add one there. Final answer here will become 5 over 3 t cubed minus 25 over 2 t squared minus 10t plus c. That looks like answer choice A to me. All right, number 55. We're still finding the integral. They're giving us, it looks really complicated. It's really a very, very easy question. You just have to re-express this using exponents, I would think. So this is what we have. Lovely question. And so step by step, we're going to bring this part of the equation up. This is going to come up. And so you're going to have negative 3x to the negative 1/3 minus 4x to the 1/2. And remember, we're adding 1 to the exponent and dividing by what's left over. So this is actually, since we're adding 3 over 3 to negative 1/3, this is really 2/3. Adding 1 again, this becomes 3 over 2. And just remember, this is 2 over 3 in the denominator, and this is 3 over 2 in the denominator as well. So we have, to simplify it, negative 3x to the 2/3 over 2/3 and minus 4x to the 3 over 2 over 3 over 2. So what we're going to do is we're now going to keep change flip. So this is going to become multiplied over here as 3 over 2. So basically 3 over 2 times negative 3x to the 2/3 minus 2 over 3 times 4x to the 3 over 2. And so this becomes, I should do it like this so you can follow vertically. This is negative 9x to the 2/3 over 2 minus 8x to the 3 over 2 over 3 plus c. And I believe that should be your answer. It's answer choice A. Okay. Let's look at number 56. Number 56, they're giving you find the integral again, but this time they're giving you 5e to the x minus 1 over x dx. And so if I do the antiderivative for this, I'm going to get basically 5e to the x minus natural log x, because that's about as straightforward as the question gets. (57) same difference. They give us the integration symbol. Find the integral. They're giving us negative x to the 8th plus 4 to the 6th power times x to the 7th power dx. Okay, so the antiderivative, remember we're going to add 1 to the numerator and divide by that. So this becomes negative 8, negative x to the 8th plus 4. And this becomes 6 plus 1, and we're dividing this by 6 plus 1. And we're multiplying this. We use power rule here. That's not. So 7 plus 1 and divide 7 plus 1. So you get x to the 7 plus 1 over 8. And so this reduces to negative 1 over 56 negative x to the 8th plus 4 to the 7th power plus c. And that's it. So the only role this actually plays here to a point is to give us this constant. Because remember, this is 7, so 7 times 8, 56. Okay, number 58. Same thing, find the integral. They give us the function te to the negative raised to the negative 7t squared plus c. So remember that this numerator is important to us because this gives us negative 14 as the antiderivative. So our constant value would be negative 1 over 14 e to the negative 7 t squared plus c. And I believe that is answer choice B. B as in boy. All right, number 59. Find the integral. They're giving us x squared, square root of x cubed plus 4 dx. So if we begin to take the antiderivative, first thing we're going to consider is that this piece, okay, so let's say we say u is equal to x cubed plus 4. And if we integrate the value, this will become the square root of u over 3. And we obtained a 3 because plus 1 divide 2 plus 1, hence 3. So we have a 1/3 constant out here. Okay, so I have 1/3 if I take this out. This further is now, if I take the constant, I'll have 1/3 times 2 over 3 u to 3 over 2. Because remember, this is u to the 1/2. If I do plus 1, that becomes 3 over 2. And I'm dividing by 3 over 2, so if I keep change flip, it becomes 2 over 3 of u, 3 over 2. And my final answer here will become 2 over 9, substituting this back, x cubed plus 4 to the 3 over 2 plus c. Okay, and number 60. We have, again, we're going to integrate, find the integral of x squared over 5x to the third plus 8 dx. So this will become 1 over 15 natural log of the absolute value of the denominator, hence 5x cubed plus 8 plus c. And that's it. If you forget how we get this, this is plus 1, and I have to multiply 3 over here. This is already 1/5. So 1/5 times 1/3, hence 1/15. Okay, and this is obviously a natural log because it's a division. All right, this is part 3. Part 4